you'll see time marching an hour at a time. What you'll see is how dynamic these winds are. We all think, oh, Tahoe, wind comes from the southwest. It does a lot of the time, but it comes from the southwest when you measure it at the airport, down here. When you're over here or over there, because of the action of the mountains and the valleys and everything, the wind is very different. Okay. Now I have to... I've got this little spinning wheel of death. Oh, yeah, that's exactly the response. It's changing. Actually, it's getting up 15 minutes at a time. The wind is highly variable. As I said before, it's the winds that are driving the motions of the lake. And so it's different. It's different every day, every hour. This is giving the maximum wind speed, 5 meters per second, 2 meters per second. It's changing. These are another kind of instrument. These are called drogues. They're like these big, giant sails that we put underwater, and we attach them with a very thin line to a cell phone or a GPS. The water currents push the sail around, and the GPS just goes along for the ride, and it tells us every minute, every 5 minutes where it is. And so what we see is where the currents are carrying these. So it's not telling us, it's not giving us the record of velocity at one point, but it's showing us what the whole field is doing. Okay. So, this is what you're going to see now are the results of releasing 4 of these drogues. We release them, I guess, across the middle here. What you're seeing at the top is the wind speed. So again, it's variable, and we're going from day 263 to 2, so you're going to see 10 or 14 days of data. So wind speed, wind direction is not that important for this. Red, blue, green, and whatever. They are the colors of the drogues you'll see, and these are showing their velocities, the speeds of the drogues. And some of them, 30 centimeters a second, a foot per second. That's pretty high. Even when it's lower, it's still 6 inches a second. Do the math. Well, you will see how quickly these things actually move. There they go. And this red line is showing you time. Look at that blue guy. And he's got a mind of his own. The thing is, this one is now close to where it started off, but it's not doing the same thing. The wind has changed. It's doing something else. They disappear sometimes because we lose the signal. Like Glenbrook.
Dead Man's Point.
Dead Man's Point. Yeah, and then there was this big storm and we lost communication with all of them, and then they all popped back. Did you see how fast that went down?
I got money on blue.
Yeah, that's right. That's what happens when you give a talk on the matter. Everybody starts betting on the outcome. Okay, so you get the idea. These things are moving.
He's seen this before, so he knew.
I know. So you have tires going, it's like 2 days between. Look at Red. Red loves Mala Bay. Went in, looked around, and said,
Come back.
not so bad. Have another look. I mean, again, the water motions are such that there's this trapping zone. These guys stick together and they go very quickly, in about half a day, from the east across to the west. The green one is run aground. Some of you have seen this, but you will, if you haven't seen it before, you will see why people never tire of seeing it. Oh, so what are you seeing? Okay, before we run it. Okay, so this is the lake divided up into 4 quadrants, and we've done the equivalent of putting floating tennis balls with different colors in each quadrant. So what these represent are particles, let's say, being moved around by the surface currents in the lake. So think of these as drogues. Instead of 3 or 4 drogues being released, we now have 1,000 drogues being released. And so as you'll see them move, you'll see it over about a 2.5 day period, you will really get a sense of how the whole lake moves. I hope. And there'll be a quiz afterwards. Dear. See how it's sort of pulsating? Why do you think it's pulsating?
Boat traffic.
Day and night, day and night.
No. Well, yes and no. It's the wind. What I'm going to show you now is, this is the southeast corner of the lake, is just a typical model result of what you would see in the southeast corner. These purple lines, this is the thick one is the 100-meter contour, and the one closest to shore is the 20-meter contour, 70 feet of water. So this is, most of this area would have been in one grid cell before. Now we have lots of grid cells in here. What you're actually seeing, what these little lines represent, is how far water travels in 2 hours in that direction. They're called streamlines. So anyway, what you'll see is pretty interesting. I'll let you judge. So this is hours going by at the top. Once again, it's extremely variable. It's changing all the time. And sometimes you can see something coming up there. You've got the currents coming here. Mile Bay, you're often getting this recirculating cell. You have this eddy there. Anybody been kayaking up there? You seen that eddy? Maybe it's not there. It's a model. But that's the sort of data that we need more of. If you go either side of this 100-meter contour, the velocities are very different. So this near shore and the pelagic, the offshore, behave very differently.